Crossing outward to the Saturn system, Voyager's images showed that Saturn's moon, Enceladus, had a similar surface. And the same was presumed of Saturn's by far largest moon, Titan, enshrouded in heavy clouds. So, when the Cassini spacecraft arrived in 2004 to scrutinize the kingdom of Saturn, it came equipped to answer a range of burning questions. Can such moons really have liquid oceans beneath their surfaces? And do those oceans have the ability to cook up and then support life? After a year in orbit, Cassini let go of its traveling companion, the Huygens probe, and sent it parachuting down towards the surface of Titan, the second largest moon in the solar system. Larger in size, in fact, than the planet Mercury, and massive enough to hold an atmosphere. Unexpected winds buffeted Huygens' parachute, but the probe was able to snatch a wealth of revealing information from the air. During its descent, Huygens' onboard radar showed a complex topography, with ridges, rivers, and lakes, and even individual rocks on the ground. Titan's atmosphere is thick and cold, the thermometer hovering just above -300 Fahrenheit. Like Earth, the air here is mostly nitrogen gas. And like Earth in our very early years, Titan's muddy, wet terrain is a stew of organic compounds. But while the liquid that cycles from ice to steam here on Earth is water, Titan's ever-changing fluid is methane. On Titan, methane gurgles up from the ground in liquid form and flows into lakes. It freezes into hydrocarbon icebergs, and it puffs off as gas in orange clouds and pinkish fog. And it may not be completely crazy to imagine some form of life arising out of this chaotic, cold, carbon-rich chemistry. Once again, the evidence points toward a moon with a rocky core, heated by tidal gravity of a massive planet, and layers of liquid and ice near the surface that burst forth in cold volcanoes and icy geysers. All of this activity has left a profound imprint upon the landscape. Repeated radar passes by Cassini reveal extensive dune fields of methane mud, wetlands, volcanic vents, and the occasional crater. And there's at least one continent, now known as Xanadu. To reach us, these images had to travel nearly 1 billion miles. At the end of their journey, they were picked up by the Deep Space Network. You can think of the DSN as an early prototype for an interplanetary internet.